Hello everyone. In this video, we will be discussing a few numericals on riveting concept. And these problems I have taken from the textbook V.K. Bandari. His name is referred as the textbook author for as per the VTU syllabus. So the first problem is design a triple riveted lap joint to join two plates of 6 mm thick. The allowable stresses are the tensile stress is 80 megapascal, compressive stress is 100 megapascal, and the shear stress is 60 megapascal. Calculate the rivet diameter, rivet pitch, and distance between the rows of rivet. Use zigzag riveting. State how the joint will fail. So this is a common type of problems. Almost these kind of problem we can expect for the examination. So let me start with the solution. Since the thickness is given as 6 mm, so as the thickness of the plate is less than 8 mm, the diameter of the rivet may be determined by equating the shearing resistance to the crushing resistance. So this is the important note you people have to remember, because the thickness is greater than 8 equation, then we can go with Mine's equation, but here it is less than 8 mm. So we have to equate that the shearing resistance to the crushing resistance. So further, as the joint is a triple riveted zigzag lap joint, there will be 3 rivets per pitch, and that I'll be showing in the coming up sketch, and which is under single shear and same number of rivets under crushing. You can able to see it is a zigzag pattern and a triple riveted welding. So triple riveted means, like the 3 rows of rivets should be there, and these values and all I have directly put, but now after calculation I will tell you how I got these values. And it is a single shear because there is no cover plates and there is no gaskets kind of things. So it is a single shear will be there both the plates, and we have to find out what is the pitch, transverse pitch, margin value, and even the diameter of the rivet hole and rivet. All these things we have to find out. So, since we have to equate the shearing stress with the crushing resistance, let me go with the equation from data handbook, that is from page 68 and the table 5.3b from the reference design data handbook. So, shearing resistance is nothing but pi d square by 4 into n into tau. So, here d is unknown and remaining values is known. So, I will be getting shearing resistance Fs is equal to 141.37 d square. Similarly, crushing resistance Fc is equal to n dt sigma c. So which is equal to 3 into, again d is unknown and t and sigma c is known. So I will be getting 1800 d. Since I have to equate both crushing resistance and the shearing resistance as per the concept, since it is less than 8 mm thickness. So I will be equating this. So from this I will be finding out the d equal to 12.73 mm. So from the design data handbook, I will be finding out the nearest standard diameter of the rivet recommended D is equal to 14 mm. So now you can able to write that the diameter of the rivet is equal to 14 mm. Along with this, we need to find out what is the rivet hole diameter, because for all the strength calculations, we need to consider the rivet hole diameter only. If the rivet diameter is 14 mm means rivet hole diameter should be greater than this one. Then once this rivet can be inserted in it. So rivet hole diameter, let me assuming it as 15 mm. So next one is the pitch of the rivets. So the pitch of the rivets may be obtained by equating the rivet tearing resistance of the plate with the shearing resistance of the rivets. So I will be going with these two equations from the data handbook, page number 66, and equation 5.31b and 31c. So tearing resistance formula is Ft is equal to sigma t p minus d into t. So in this, except p, remaining values are unknown. So I will be getting the values as p minus 14 into 6 into 80. So this is 480. So I'll be writing p minus 14 into 480. Similarly, shearing resistance formula is Fs is equal to n into pi d square by 4 into tau. Here I'll be substituting all the values since it is a known thing. So it is 3 into pi into 14 square divided by 4 into 60. So I'll be getting 27,708.8 Newton. So since the pitch of the rivet can be obtained by equating the tearing resistance of the plate to the shearing resistance. I'll be equating these two, that is P minus 14 into 480, which is equal to 27,708.8. So after simplification, I'll be getting pitch is equal to 71.73 mm, and let me round it off and say it is 72 mm. And the distance between the row of rivets, that is the PB or the transverse pitch, the formula is 0.33 P plus 0.67 D, and after substituting the P value as 72 in this formula, I'll be getting the transverse pitch value as 33.14 mm, and let me round it as 34 mm. Now we have the mode of failure of the joint, that is the tearing efficiency and crushing efficiency, where tearing efficiency is equal to P minus D by P, that is 72 minus 14 divided by 72, which is 0.801, that is 80.1 percentage, and crushing efficiency ND T sigma C divided by PT sigma T. So the answer is 0.802, that is 80.2 percentage. So the lowest efficiency indicates the mode of failure of the joint. In the present case, the joint will fail by the crushing of the rivet. Then similarly, we'll see the second problem, that is again from the author V.K. Bandari. The question is a double riveted zigzag butt joint in which the pitch of the rivet in the outer row is twice that in the inner rows. Connects two 16 mm plates with two cover plates, each 12 mm thickness. Determine the diameter of the rivets and the pitch of the rivets. And the pitch of the rivets, if the working stress are tensile stress 100 megapascal, crushing stress 150 megapascal, and shear 75 megapascal. And since the thickness is greater than 8 mm, so I can go with the formula. First solution, diameter of the rivet, let me find out by using the formula, that is D equal to 6 root of T. So here I'll be T is a given known value, so I'll be finding out the D. And the pitch of the rivet, let me write down PO is nothing but pitch of the rivet in the outer row, and PI is nothing but pitch of the rivet in the inner row. So the pitch of the rivets may be obtained by equating the tearing resistance of the plate to the shearing resistance of the rivets. So by referring this figure, I can able to see this. The pitch in the outer row is twice the pitch of the inner row. You can able to see this. So for one pitch length in the outer row, there are three rivets which are under double shear. You can able to see this. This is a double shear. So this is a double riveted double strap zigzag butt joint. So first, let me first find out the tearing resistance, and later let me find out shearing resistance. Tearing resistance Ft is equal to P minus D into T into sigma T, where P is nothing but the outer pitch. So I'll be getting the value tearing resistance as P naught minus 24 into 1600 Newton. And similarly, shearing resistance Fs is equal to N into 1.875 into pi d square by 4 tau. Assuming that the rivets under double shear are 1.875 times as strong as those under single shear, that is 3 into 1.875, because inside 3 in the inside row 3 rivets are there, so that is why it is 3 into 1.875 into pi by 4 into 24 square into 75, so it is 190851.8 Newton. So I'll be equating tearing resistance with the shearing resistance, so I'll be getting the outer pitch is equal to 143.3 mm. After rounding off, it is 144 mm. And the pitch of the rivets in the inner row, that is nothing but half of the outer pitch, that is 144 by 2, that is 72 mm. Then the distance between row of the rivets. For the zigzag riveting, the row, that is the back pitch PB is greater than or equal to 0.2 PO plus 1.5 D greater than or equal to, so 0.2 into 144 plus 1.15 into 24, which is greater than or equal to 56.4 mm. So a back row pitch of 60 mm may be recommended. So with this, I'll be winding up this video. In the upcoming video, we will be discussing numericals on welding. Thank you.